Welcome back. I finished charging my camcorder. Got a shower this evening. The sun is shining and it's very hot in my living room. It's feeling very hot. So I got a shower this evening. I just upload some video. So let's finish up reading the last part. It maybe works up, maybe not. Sometime it will not start again, but I'll not touch anything.
The F-104 series all had a very high wing loading, made even higher when carrying external stores. During the early stall tests, the aircraft demonstrated the tendency to suddenly pitch up once it reached an angle of attack of approximately 15 degrees. This pitch up would result in a rapid increase in angle of attack to approximately 60 degrees, accompanied by lateral and directional oscillation, and followed by sudden uncontrolled yaw and roll. At this point the aircraft would be essentially tumbling, descending at a rate of 12,000 15,000 feet per minute, 3,704,600 m forward/min. To combat this, an automatic pitch control, APC, was added, which initiated corrective action at the proper time to prevent reaching an angle of attack high enough to cause pitch up under any operating condition. The high angle of attack area of flight was protected by a stick shaker system to warn the pilot of an approaching stall, and if this was ignored, a stick pusher system would pitch the aircraft's nose down to a safer angle of attack. This was often overridden by the pilot despite flight manual warnings against this practice. Another serious design issue that the aircraft encountered was T-tail flutter. Dick Hepp, who served as the initial project aerodynamics engineer for the F-104 program, recalled that without question, the single most difficult technical challenge encountered in the F-104 and F-104 development programs was the catastrophic flutter problem of the unique T-tailed empennage configuration. Because the horizontal tail's center of gravity was well aft of both the bending and torsional axes of the vertical tail to which it was attached, it was highly vulnerable to flutter at transonic speeds. During a test flight of the F-104, the surviving F-104 was flying chase to observe, and encountered violent T-tail flutter that caused the tail to separate from the aircraft. The test pilot of the F-104 successfully ejected. This behavior was remedied by increasing the thickness of the stainless steel box covers used in the tail assembly. The J-79 was a brand new engine, with development continuing throughout the YF-104 test phase and during service with the F-104. The engine featured variable incidence compressor stator blades, a design feature that altered the angle of the stator blades automatically with altitude and temperature. A condition known as T2 reset, a normal function that made large stator blade angle changes, caused several engine failures on takeoff. It was discovered that large and sudden temperature changes, for example, from being parked in the sun prior to becoming airborne, were falsely causing the engine stator blades to close and choke the compressor. The dangers presented by these engine failures were compounded by the downward ejection seat, which gave the pilot little chance of a safe exit at low level. The engine systems were subsequently modified and the ejection seat changed to the more conventional upward type. Uncontrolled oscillations of its wingtip-mounted fuel tank sheared one wing off of an F-104B. This problem was apparent during testing of the XF-104 prototype and was eventually resolved by filling the tank compartments in a specific order. Early F-104s also lacked modulated afterburning, and as a result combat operations could only be performed at one of only two settings, either maximum military power or full afterburner. Effectively, this gave the pilot the choice of two level flight speeds, Mach 1 or Mach 2.2. Later problems, edit. A further engine problem was that of uncommanded opening of the variable thrust nozzle, usually through loss of engine oil pressure, as the nozzles were actuated using engine oil as hydraulic fluid. Although the engine would be running normally at high power, the opening of the nozzle resulted in a drastic loss of thrust to below that required to maintain level flight. At low altitudes this was unrecoverable, and it caused the loss of at least 7 F-104s during testing. A modification program installed a manual nozzle closure control that reduced the problem, but according to designer Kelly Johnson, this took 9 years to resolve satisfactorily. The engine also suffered from afterburner blowout on takeoff, or even non-ignition, resulting in a major loss of thrust that could be detected by the pilot. The recommended action was to abandon the takeoff. The first fatal accident in German service was caused by this phenomenon. Some pilots experienced uncommanded stick kicker activation at low altitudes while flying straight and level, so F-104 crews were often directed to deactivate it for flight operations. Asymmetric or split flap deployment was another frequent cause of accidents. Many pilots also experienced severe nose wheel shimmy on landing, which usually resulted in the aircraft leaving the runway and in some cases even flipping over onto its back. West German service, edit. The introduction of a highly technical aircraft type to a newly reformed Air Force was fraught with problems. Many pilots and ground crew had settled into civilian jobs after World War II and had not kept pace with developments, with pilots being sent on short refresher courses in slow and benign handling first-generation jet aircraft. Ground crew were similarly employed with minimal training and experience, which was one consequence of a conscripted military with high turnover of service personnel. Operating in the poor weather conditions of Northwest Europe, unlike the fair weather training conditions at Luke AFB in Arizona, and flying low at high speed over hilly terrain, many accidents were attributed to controlled flight into terrain, CFIT. A total of 116 pilots were lost in West German F-104 accidents, including 1 ground crew passenger and 8 USAF instructors. One contributing factor to this was the operational assignment of the F-104 in West German service. It was mainly used as a low-level fighter bomber, as opposed to the original design of a high-speed, high-altitude fighter forward/interceptor. Furthermore, the installation of additional avionic equipment in the F-104G version, such as the inertial navigation system, added distraction for the pilot, as well as extra weight that further hampered the flying capabilities of the plane. In contemporary West German magazine articles highlighting the Starfighter safety problems, the aircraft was portrayed as overburdened with technology, which was considered a latent overstrain on the aircrews. In 1966, Johann Steinhoff took over command of the Luftwaffe and grounded the entire Luftwaffe and Bundesmarine F-104 fleet until he was satisfied that problems had been resolved or at least reduced. In later years, the safety record improved, although a new problem of structural failure of the wings emerged. Original fatigue calculations had not taken into account the high number of GeForce loading cycles that the F-104 fleet was experiencing, and many airframes were returned to the depot for wing replacement or outright retirement. Towards the end of Luftwaffe service, some aircraft were modified to carry a flight data recorder or black box, which could give an indication of the probable cause of an accident. Erich Hartmann, the world's top-scoring fighter ace, commanded one of West Germany's first post-war jet fighter-equipped wings and deemed the F-104 to be an unsafe aircraft with poor handling characteristics for aerial combat. In Navy service it lacked the safety margin of a twin-engine design such as the Blackburn Buccaneer. To the dismay of his superiors, Hartmann judged the fighter unfit for Luftwaffe use even before its introduction. Eric Brown described the Starfighter as a hot ship that has to be flown every inch of the way. The USAF required Starfighter pilots to have at least 1,500 flight hours of experience prior to flying the F-104. West German pilots had around 400 hours. Brown recommended the Blackburn Buccaneer instead. Normal operating hazards, edit. The causes of a large number of aircraft losses were the same as for any other similar type. They included bird strikes and other foreign object damage, particularly to the engine, lightning strikes, pilot spatial disorientation, and mid-air collisions with other aircraft. One such accident occurred on the 19th of June, 1962 when a formation of 4 F-104F aircraft, practicing for the type's introduction into service ceremony the following day, crashed together after descending through a cloud bank. The pilot of the lead aircraft lost spatial orientation and was at too steep a nose-down angle to recover. 3 German pilots and 1 American pilot were killed, and the 4 aircraft destroyed. As a result, formation aerobatic teams were immediately banned by the Luftwaffe. Safety record, edit. The safety record of the F-104 Starfighter became high-profile news in the mid-1960s, especially in West Germany. West Germany initially ordered 309 F-104s, and over time another 607. Deliveries of Lockheed-built aircraft started in August 1961, and domestically produced airframes began to roll off the assembly lines in December. That same month, the first of an eventual total of 292 West German F-104s had crashed. In October 1975, Lockheed agreed to pay a total of 3 million Deutsche Marks, $1.2 million, to approximately 60 widows and dependents of 32 Luftwaffe pilots killed during flight operations, though the company declined to admit liability. While announcing the settlement, the plaintiff's attorney acknowledged he had been seeking $10 million and noted that there were more instances of pilot error than he had expected. The second XB-70 Valkyrie prototype flies in formation with other GE-powered aircraft for a photo shoot, the 8th of June, 1966. Shortly after this photograph was taken, the F-104, Red Tail, on the XB-70's right, and XB-70 collided, killing the F-104 pilot Joe Walker and the co-pilot of the XB-70. Some operators lost a large proportion of their aircraft through accidents, although the accident rate varied widely depending on the user and operating conditions. The German Air Force and Federal German Navy, the largest combined user of the F-104 and operator of over 35% of all airframes built, lost approximately 32% of its starfighters in accidents over the aircraft's 31-year career. The Belgian Air Force, on the other hand, lost 41 of its 100 airframes between February 1963 and September 1983, and Italy, the final Starfighter operator, lost 138 of 368, 37%, by 1992. Canada's accident rate with the F-104 ultimately exceeded 46%. 110 of 238, over its 25-year service history, though the Canadian jets tended to be flown for a greater number of hours than those of other air forces, 3 times that of the German F-104s, for example. However, Some operators had substantially lower accident rates. Denmark's attrition rate for the F-104 was 24%, with Japan losing just 15% and Norway 14%, 6 of 43, of their respective Starfighter fleets. The best accident rate was achieved by the Spanish Air Force, which ended its Starfighter era with a perfect safety record. The Ejército del Aire lost none of its 18 F-104GS and 3 F-104GS over a total of 7 years and 17,500 flight hours. The cumulative destroyed rate of the F-104 Starfighter in USAF service as of the 31st of December, 1983 was 25.2 aircraft destroyed per 100,000 flight hours. This is the highest accident rate of any of the USAF Century Series fighters. By comparison, the cumulative destroyed rates for the other Century Series aircraft in USAF service over the same time period were 16.2 for the North American F-100 Super Sabre, 9.7 for the McDonnell F-101 Voodoo, 15.6 for the Republic F-105 Thunderchief, and 7.3 for the Convair F-106 Delta Dart. By comparison, the Royal Australian Air Force, RAF, experienced an overall loss rate of 11.96 per 100,000 flying hours with the Dassault Mirage 3, losing 40 of 116 aircraft to accidents over its 25-year career from 1965 to 1989. The Royal Air Force lost over 50 of 280 English Electric Lightnings, at one point experiencing 12 losses in the 17 months between January 1970 and May 1971. The loss rate per 100,000 hours from the introduction of the Lightning in 1961 to May 1971 was 17.3. higher than the lifetime West German Starfighter loss rate of 15.08. Notable USAF pilots who died in F-104 accidents include Major Robert H. Lawrence Jr. and Captain Ivan Kinchelow. Civilian, former USAF pilot Joe Walker died in a mid-air collision with an XB-70 Valkyrie while flying an F-104. Chuck Yeager was nearly killed in December 1963 when he lost control of an F-104 during a high-altitude record-breaking attempt. He lost the tips of 2 fingers and was hospitalized for a long period with severe burns after ejecting from the aircraft. Variants, edit. Main article, list of Lockheed F-104 Starfighter variants. XF-104. Main article, Lockheed XF-104 Starfighter. This was the prototype aircraft. 2 examples were built and powered by Wright J-65 engines. The J-79 was not yet ready. The second prototype was equipped with the M61 cannon as an armament test bed. Both aircraft were destroyed in crashes. YF-104. The YF-104 was a pre-production aircraft used for engine, equipment, and flight testing. 17 were built, with the first flight taking place on the 17th of February, 1956 and reaching Mach 2 for the first time on the 27th of April. F-104. This aircraft was the initial production single-seat interceptor version, very similar to the YF-104. A total of 153 were built. The F-104 was in USAF service from 1958 through 1960, then transferred to the Air National Guard until 1963. At that time they were recalled by the USAF Air Defense Command for the 319th and 331st Fighter Interceptor Squadrons. Some were released for export to Jordan, Pakistan, and Taiwan, each of which used it in combat. The 319th F-104s and BS had their engines replaced in 1967 with the J79 GE19, which provided 17,900 lbf, 79.6 kN, of thrust in afterburner. The service ceiling with this engine was in excess of 73,000 feet, 22,000 m. In 1969, all the F-104/BS in ADC service were retired. On the 16th of May 1958, an F-104 flown by USAF Captain Walter W. Irwin set a world flight airspeed record of 1,404.012 miles per hour, 2,259.538 kilometers per hour. NF-104. Main article, Lockheed NF-104. The NF-104 was used for 3 demilitarized versions with an additional 6,000 lbf, 27 kN, Rocketdyne LR-121/R2Na-1 rocket engine, used for astronaut training at altitudes up to 120,800 feet, 36,800 m. QF-104. A total of 24 F-104s, 4 YF-104s, 20 early F-104s, were converted into radio-controlled drones and test aircraft. These target drones were able to be flown by onboard pilots as well as remotely controlled by pilots using radio control equipment either on the ground or flying in other aircraft. F-104B. The F-104B was a tandem two-seat, dual-control trainer version of the F-104. A total of 26 built, the F-104B had an enlarged rudder and ventral fin, no cannon, and reduced internal fuel, but was otherwise combat-capable. A few were supplied to Jordan, Pakistan, and Taiwan. F-104C. A fighter bomber for USAF Tactical Air Command, the F-104C had improved fire control radar, and forward/ASG-14T2, 1 centerline and 2 pylons under each wing, for a total of 5, and the ability to carry 1 Mk-28 or Mk-43 nuclear weapon on the centerline pylon. The F-104C also had in-flight refueling capability. 77 F-104Cs were built. On the 14th of December, 1959, an F-104C set a world altitude record of 103,389 feet, 31,513 m. F-104D. The F-104D designation was a dual-control trainer version of the F-104C. 21 examples were built. F-104DJ. This aircraft was a dual-control trainer version of the F-104J for the Japanese Air Self-Defense Force, JASDF. Lockheed built 20 F-104DJs, assembling the first at their Burbank facility, and shipping the remaining 19 to Japan for assembly by Mitsubishi and Kawasaki. After their retirement in Japan, the United States delivered some of these F-104J forward/DJs to the Taiwanese Air Force. F-104F. The F-104F designation was given to a dual-control trainer based on the F-104D, but using the upgraded engine of the F-104G. It had no radar, and was not combat-capable. The F-104F was produced as an interim trainer for the German Air Force. All 30 F-104F aircraft were retired by 1972. F-104G. The F-104G was the most produced version of the F-104 family, a multi-role fighter bomber with a total of 1,127 aircraft built. They were manufactured by Lockheed, as well as under license by Canadair and a consortium of European companies that included Messerschmitt/MBB, Fiat, Fokker, and Subka. The type featured a strengthened fuselage, wing, and empennage structures. The larger vertical fin with fully powered rudder as used on the two-seat versions, fully powered brakes, a new anti-skid system, and larger tires, revised flaps for improved combat maneuvering, and a larger braking chute. Upgraded avionics included the Autonetics NASAR F-141B radar with air-to-air, ground mapping, contour mapping, and terrain avoidance modes, as well as the Litton LN-3 inertial navigation system, the first on a production fighter. RF-104G. The RF-104G was a tactical reconnaissance model based on the F-104G, usually with 3 KS-67A cameras mounted in the forward fuselage in place of the internal cannon. Many of the 189 built were subsequently reconfigured to the F-104G standard. TF-104G. A combat-capable trainer version of the F-104G. The TF-104G had no cannon or centerline pylon, and reduced internal fuel. One of the 220 aircraft produced was used by Lockheed as a demonstrator with the civil registration number N104L, and was flown by Jackie Cochran to set 3 women's world speed records in 1964. This aircraft later served in the Netherlands. A pair of two-seat TF-104GS joined the NASA Dreden inventory in July 1975 along with a Fokker-built former RF-104G. F-104H. The F-104H was a projected export version based on the F-104G with an optical gun sight and simplified equipment. It was cancelled prior to construction. F-104J. The F-104J was a specialized interceptor version of the F-104G for the Japanese ASDF, built under license by Mitsubishi for the air superiority role. It was armed with cannon and 4 sidewinders, but had no strike capability. Some were converted to UF-104J radio-controlled target drones and destroyed. A total of 210 were built, 3 by Lockheed, 29 by Mitsubishi from Lockheed-sourced components, and 178 by Mitsubishi. After being retired in Japan, the US delivered some of these 104J /DJs to the Air Force of Taiwan. F-104N. 3 unarmed and lighter F-104GS were delivered to NASA in 1963 for use as high-speed chase aircraft and given the designation F-104N. 1. Piloted by Joe Walker, collided with an XB-70 on the 8th of June, 1966. F-104S. Main article, Air Italia F-104S. Fiat built 246 of the final production version, the F-104S. One of these aircraft crashed prior to delivery and is often not included in the total number produced. 40 of these aircraft were delivered to the Turkish Air Force and the rest to the Italian Air Force, Aeronautica Militare Italiana. The F-104S was upgraded for the interception role, adding the NASAR 21G/H radar with moving target indicator and continuous wave illuminator for semi-active radar homing missiles, initially the AIM-7 Sparrow, 2 additional wing and 2 underbelly hard points, increasing the total to 9, the more powerful J-79GE-19 engine, and 2 additional ventral fins to increase stability. The M61 cannon was sacrificed to make room for the missile avionics in the interceptor version, but was retained for the fighter-bomber variant. Typically 2 Sparrow and 2, and sometimes 4 or 6, Sidewinder missiles were carried on all the hard points except the central, underbelly, or up to 750 pound, 340 kilograms, bombs, normally 2 to 4 750 pound, 233 40 kilogram, bombs. The F-104S was cleared for a higher maximum takeoff weight, allowing it to carry up to 7,500 pound, 3,400 kilograms, of stores. Other starfighters had a maximum external load of 4,000 pound, 1,800 kilograms. Its combat radius was up to 775 mi, 1,247 kilometers, with 4 external fuel tanks. F-104S ASA, Aggiornamento Sistemi di Armor Weapon Systems Update. This was an upgraded F-104S